students. In previous class, we discussed about problems on ellipse, and in this class, we will do some more problems on ellipse, and we will learn how to do the problems. Today's class objectives. On completion of this period, you would be able to solve problems on ellipse when different elements are given. So, recap. Up to now, what we learned, we will recall it. For an ellipse, x square by a square plus y square by b square equals to 1. Length of major axis equals to 2a. Length of minor axis equals to 2b. Distance between foci equals to SS1 equals to 2 into AE. Distance between directrices ZZ1 equals to 2 into A by E. Distance between vertices equals to A1 equals to 2A. A length of lattice rectum equals to 2b square by A. In previous class, the ellipse equation is given and asked for its elements. And today's class, we are asking equation of the ellipse and given its parts or its elements. So let us see the first question. Find the equation of the ellipse whose focus is 1, minus 2. Directrix is the line. 3x minus 2y plus 1 equals to 0, and eccentricity is 1 by root 2. So focus, directrix and eccentricity are given. So we have direct formula to find ellipse equation, that is x minus x1 whole square plus y minus y1 whole square equals to e square into ax plus by plus c whole square by a square plus b square. So this is a very easy question and important question, and if we know the formula, we can find equation of the ellipse, and after expansion and simplification we will get the equation of the ellipse. Solution. Given that focus is at S 1, minus 2. Equation of the directrix is 3x minus 2y plus 1 equals to 0. Eccentricity E equals to 1 by root 2. We know that the equation of the ellipse with focus at S x1, y1 ax plus by plus c equals to 0 as directrix, and eccentricity E is x minus x1 whole square plus y minus y1 whole square equals to e square into ax plus by plus c by under root of a square plus b square whole square. So if we know the formula, we can do this problem. And here in the left side, x minus x1 should kept in a bracket, and y minus y1 also kept in bracket. Here x1 y1 is 1 comma minus 2, and directrix is ax plus by plus c means 3x minus 2y plus 1, e means 1 by root 2, ab means 3 and minus 2. So substitute and then expand it, then we get like this: 26 into x square minus 2x plus 1 plus y square plus 4y plus 4 equals to 9x square plus 4y square plus 1 minus 12xy plus 6x minus 4y. On simplification, we get 17x square plus 22y square plus 12xy minus 58x plus 108y plus 129 equals to 0. Second one. Find the equation of the ellipse whose center is at the point 4, 3. The eccentricity is 4 by 5 and length of latus rectum is 8. So here center, eccentricity and length of latus rectum are given. Solution: given that center is at C 4, 3, eccentricity equals to 4 by 5, length of latus rectum equals to 2b square by a, that equal to 8. B square equals to 4a. Consider it as equation 1. We know that b square equals to a square into 1 minus e square for an ellipse. So 4a equals to a square into 1 minus e means 4 by 5 whole square. So on simplification, a equals to 100 by 9. Then a square equals to 100 by 9 whole square. Then b square equals to 4 into 100 by 9, that equals to 400 by 9. Hence the required ellipse is x minus h whole square by a square plus y minus k whole square by b square equals to 1. For x minus 4 whole square by 100 by 9 whole square plus y minus 3 whole square by 400 by 9 equals to 1. So 81 into x minus 4 whole square by 100 square plus 9 into y minus 3 whole square by 20 square equals to 1 is the required ellipse. Here, from given data, we get a equals to 100 by 9. Then we get b value or b square value, then the equation of the ellipse we got. So here center is 4, 3 means we can say it is a third form, so that we compare, and here we know a is greater than b, that's why we fixed it is in the form of third, so that we substituted and simplified, and finally we got the equation of the ellipse. Next question, find the equation of the ellipse whose center is 4, 0, semi-major axis is 4 and parallel to x-axis, semi-minor axis is 3. Center is given and it is not a origin, so given equation is belongs to either third or fourth. So major axis is parallel to x-axis means it is belongs to third form only. So we know the third form and we have to find for a and b. Then we know the equation of the ellipse. Given that center is at C 4, 0, length of semi-major axis equal to A equals to 4. Length of semi-minor axis equals to B equals to 3. And major axis parallel to x-axis, we know that equation of the ellipse with center at C, H, K and major axis parallel to x-axis. Equation of the ellipse is x minus h whole square by a square plus y minus k whole square by b square equals to 1. That is x minus 4 whole square by 4 square plus y minus 0 whole square by 3 square equals to 1. So that is x minus 4 whole square by 16 plus y square by 9 equals to 1. Here x minus 4 should be kept in the bracket. Here printing is missing. So this is the equation of the ellipse. See, when is giving the data or elements, we can select which is near to the form or which one shoots the form among the 4 forms. So if we observe, the center is not origin, means definitely 1 and its first and second forms are not belongs to the equation. Then we have to go for third and fourth. In the third and fourth, if A is greater than B, then it is a third form, or major axis is parallel to x axis, then also we can fix it is a third form. So like this we can know the equation and substitute in that equation, and we will get the desired equation of the ellipse. Fourth question. Find the equation of the ellipse whose axes are the axis of coordinate axis. Distance between foci is 10 and distance between directrices is 24. Solution. Given that axis of the ellipse or axis of the coordinate axis, that means it is belongs to first or second form. Among first and second, we have to select only one form. So to select the one form or required form, we have to observe the given data. Then we can say which one is suitable for this given elements. Distance between foci equals to 2AE equals to 10. Then AE equals to 5. Let the equation is 1. Consider the equation as a 1. Distance between directrices Z1 equals to 2A by E equals to 24. Then A equals to 12E. Consider it as a equation 2. Then from 1 and 2 we have 12E square equals to 5. That implies E square equals to 5 by 12. Then A square equals to 144 E square. From 2, that equals to 144 into 5 by 12. That equals to 60. As B square equals to A square into 1 minus E square. That equals to 60 into 1 minus 5 by 12. That equals to 35. Hence the required ellipse is x square by 60 plus y square by 35 is equals to 1. So here a is greater than b, that means we can say it is belongs to first form. See the next question, number 5. Find the eccentricity of the ellipse whose lattice rectum is same as the distance between the foci in length. Here asking eccentricity of the ellipse. The condition is whose lattice rectum is same as the distance between the foci in length. So distance between the foci we know that is 2AE, and lattice rectum is we say 2b square by a. So 2b square by a equals to 2AE. Let us see. From that we have to express, or we have to find eccentricity. Given solution. Given that length of lattice rectum equals to distance between foci, that is 2b square by a equals to 2AE. Then 2 get cancelled. We have b square equals to a square into e. In the left side denominator, if it goes to right side, it is multiply and a into a square. So b square equals to a square into e. Then we want eccentricity, so e equals to right side a square is if it is multiplied with e, so if it went to left side it becomes in the denominator, or it divides, so it divides to b square, so e equals to b square by a square. So this is how we got eccentricity in terms of b square and a square. Summary. In this session you have learned to solve problems on ellipse. Here the elements are given and we find ellipse equation. Sometimes they give an equation of the ellipse and asks us to find elements. So there is a two-way questions. Either asks ellipse equation or asks the elements of the equation. So the question comes in any way, we have to observe and compare with standard form, then we will get required answer or solution. Questions from previous papers. Number 1. find the equation of the ellipse whose focus is -1 comma 1. Directrix is the line x minus y plus 3 equals to 0, and eccentricity is 1 by 2. Number 2, find the eccentricity of the ellipse whose latus rectum is equal to half of the minor axis. In the first question, focus directrix eccentricity is given means it is a formula based question. We know the formula. When focus directrix eccentricity are given, then the equation of the ellipse is x minus x1 whole square plus y minus y1 whole square equals to e square into ax plus by plus c whole square by a square plus b square. And in the second question, here asking eccentricity. The condition is whose latus rectum is equal to half of the minor axis. So length of latus rectum is, we know that is 2b square by a, and half of the minor axis, length of minor axis is 2b. Half of the minor axis means b. So 2b square by a equals to b. And from that we have to find eccentricity. So 2b square by a equals to b means bb get cancel and 2b equals to a. Then 2b equals to a, that means a equals to 2b. And generally eccentricity formula is under root of 1 minus b square by a square. So in place of a we have to substitute 2b, then eccentricity is, comes in terms of b. In the first question, you substitute the values, then you will simplify or expand and simplify, then you will get the equation. In the second, we know the eccentricity in the form of or in the terms of b or a. We can express in terms of a or in terms of b. A equal to 2b, then b equals to a by 2. Assignment. Find the equation of ellipse whose focus is -1 comma 1 and directrix x minus y plus 3 equals to zero. Eccentricity is 1 by 2. See, focus directrix eccentricity is given means the formula is again we have to write and substitute the values. The formula is x minus x1 whole square plus y minus y1 whole square equals to e square into ax plus by plus c whole square by a square plus b square. This is an important formula because this formula came in parabola and comes in hyperbola also. In parabola, we need not to write e because its value is 1. So substitute the values and expand and simplify, then we know the equation of the ellipse. Second question. Find the equation of the ellipse whose latus rectum is 15 by 2 and distance between the foci is 2, with axis being coordinate axis. Axis being coordinate axis means the equation is either first form or second form. Generally, it is a first form because axis being coordinate axis means maximum we can consider it as a first form. And if you observe the remaining data, it is easy to know the equation of the ellipse. So whose latus rectum is 15 by 2 means 2b square by a equals to 15 by 2. The distance between foci is 2ae equals to 2. 2 get cancelled. ae equals to 1. And if we know the e square formula, e square equals to under root of 1 minus b square by a square. Here e square means we can take 1 by a and 2b square by a equals to 15 by 2. From that we know b square value, and if you substitute, then the equation will convert into in terms of a, and if we simplify we get a. Then after we get b, so the required equation is x square by a square plus y square by b square equals to 1. So if we substitute, we will get the equation of the ellipse. So we have to know, we have to bring the equation in only the form of single term, that is either a or either b only. Then after simplification, we know that single term or single value or a value or b value. So before going to do, we have to think what are the elements are given in the question. and from that we have to analyze which equation is nearer among four equations of the ellipse. Then if we know, compare it or take it and substitute and simplify, then we can get the answer. Second thing, some questions are we cannot decide based on the question directly which form it is shoots, or we cannot take the values of A, B, E or HK. In this criteria or in this situation, we have to think and we have to build the relation between what are the elements given, and the relation must be, we have to form in either only A terms or B terms. That is, in a single term, if we form like an equation and if we solve, we will get A value or B value, then it is easy to bring the equation of the ellipse for us. So what the elements are given, you have to take and substitute in the formulas, and for them, using eccentricity formula, you can build the new equation in a one term, either it is A or in terms of B. Then if you know one value, that is A or B, again if you substitute in the eccentricity formula or latus rectum formula or Foci formula, you will get B value also. So Foci if you got, then you know the center value. So this is the method how to do the equations for ellipse, or how to find the equations of the ellipse based on given elements. And when you want to do exercise problems, better first go for example problems which are given in textbook. Generally, all examples are related to exercise problems. So if we know the example problems, if we know the solutions of example problems, or if we understand the example problems, each step, then we know the concept, and as well as we know how to find exercise problems. Then you easily do the exercise problems. Before going to exercise problems, first write down the question and read it twice or thrice, because if you understand the question, then you have to analyze the question, and you can think the formulas actually are related to or belongs to the which standard form it is suitable. Then you write the elements according to formulas and compare it, and to know the equation what we have to need the elements or terms that we have to find, and at the last we have to substitute. So sometimes you have to understand the data and think which form is suitable. Sometimes based on data you can imagine the diagram, then you can clearly know which formula we have to take for elements or equation, whatever it may be we need. If you picturize or if you draw the figure of the diagram ellipse, then based on diagram also sometimes we can easily know we can easily solve the question. So mostly here, if you observe, 3 types of questions are asking. Number 1 is giving some elements of the ellipse or parts of the ellipse, and at the end he is asking equation of the ellipse. And the second type is he gives only elements or he gives only equation of the ellipse. If the equation is given, he is asking elements. That is first type. If the elements are given, he is asking equation. This is second type. And third type is he is asking particularly eccentricity, and sometimes for eccentricity is giving a equation, and sometimes to find eccentricity is giving some elements. So if the equation is given, we can find eccentricity easily because we compare the equation and we know the a values, b values from the equation by comparing the standard equation. Then we substitute in the eccentricity formula, then we can know or we can find easily the eccentricity. Sometimes the equation is not giving, only giving elements, and sometimes elements also not given clearly. Elements also is given like a particular condition. So and so length is equals to so and so distance, like this. So in this criteria we have to, or in this type of questions if we are given, we have to think, and according to the condition we have to write the formulas and simplify. Then we have to take another required formula like eccentricity and substitute in terms of a or b, then we know a value, then after b value, then at finally we find e value. Like this we can do the problems. So majorly three types of problems are occurring, or we can observe from exercise. So try to do exercise problems, and while doing, if you have any doubts, refer example problems. Till you have any doubt, you can ask me or call me. You can message me on WhatsApp, then I will clear your doubts, or we will discuss in the next class also. So take care and try to do problem.